Probability. So using set complement. So the idea of the set complement, which is denoted with this C here, so this says complement. So this is just all values not in A. So if you take the union of the set with its complement, you get the entire universe. You get all possible outcomes here. So union of the set with its complement gives you all possible outcomes. So we're talking about an interval here. This would be something like x less than 2, less than or equal to 2. Then the complement would be x greater than 2, right? And so then you union them together and you get, the entire real line. So that's one example of that. Okay, in terms of probability, though, the outcome of the universe, so having some event happen in the universe, is 1. And the probability of seeing 1 in the set or in its complement, so you have to add them together and you're going to get 1. Okay, so how is this useful? Well, maybe one of these is easier to calculate than the other, and so 1 minus the probability of seeing something in A is going to be the probability of seeing something in A complement, or 1 minus probability of seeing something in the complement of A is chance of seeing it in A, right? You just subtract it from 1. Okay, so that's great. Why would you want to do that? Well, maybe one of these is easier to compute than the other, but you actually want the one that's hard to compute. Well, you find the one that's easy and subtract it from 1 to get the one that's hard. Okay, so just as an example, let's do a fair die. So we know the outcomes of this are 1/6 for all of them. Okay, and we're being asked what's the chance of seeing an observation that is greater than or equal to 3. So this is the one that we're interested in, is the size of the green set here. And the complement of that is the chance that p is not greater than or equal to 3. So p is x is less than 3, which in this case is p is less than or equal to 2. So together, these are going to be 1 for the fair die roll. Okay. Now let's say we want this one, but we are only able to easily compute, or we can easily compute this one, but this is the one we actually want. So you do p1 minus the probability of seeing 2 or fewer, and that would be the probability of seeing 3 or more. So the probability of seeing 2 or fewer is 2 out of 6. 1 minus that is 4 out of 6, which... Okay, now because this is a fair die roll, this was probably a very obvious answer. So you didn't necessarily have to use the complement for it, but this might have been more difficult. Something like the Poisson distribution, that's where you have the tail region. They get really small. It's difficult to compute that because it's an infinite sum, but it's easier to compute the other side because it's finite. Doing something like with the normal curve, you may be able to have a function that quickly gets you that, but you really want the tail region, which is an infinite zone. I mean, it's unbounded, so it's harder to compute, but this region with finite bounds is easier, so you compute that and then subtract it from 1.